Good morning, everybody. I hope you're having a nice start to your week. Just continue plugging away. If you have questions, email me or schedule a Zoom or something. I know we're starting to get towards the end, so make sure that you schedule with enough time so that I can help you out. Okay, so right now I'm on page 6 of chapter 7. Yep, page 6 of chapter 7. There we go. So we talked about the hypotheses. We talked about like the null hypothesis, the alternative hypothesis. Alternative has just an inequality where the null hypothesis has something with an equal in it, so greater than or equal to, less than or equal to, equal to. Okay, so now I think I finished the page before that. Yeah, I did. Okay. Did I? Yes, I did. I did. Okay, we are on page 6. Sorry. So there are 3 types of hypothesis testing. Now, when you are deciding which type of hypothesis test to use, refer to the alternative hypothesis each and every time. Okay, so they're going to make a claim. You have to decide whether that's the alternative or the null. And then whatever it is, you find the complement of it. But the alternative is the one that tells you which type of hypothesis test it is. So if the alternative hypothesis contains a less than symbol, then the hypothesis test is a left-tailed test. Okay, so it'll look something like this. So if the alternative hypothesis has mu is less than k, then that means for the null, for the null, I already wrote that down, its mu is greater than or equal to k. And then the way it'll be drawn is something like this. It'll be shaded in over here. So that shading right there is P. Okay, and then this guy right here is the standardized test statistic. Okay, so that's for a left-tailed test. Now, let's say if the alternative hypothesis contains a greater than symbol, then the hypothesis test is right-tailed. It's a right-tailed test. There we go. Okay, so if the alternative hypothesis says that mu is greater than k, then and it doesn't matter which one's the claim. I mean, either one of them could be the claim, but it's just if it has one of these. So that means for the null, it's got to be less than or equal to. Okay, and the way we draw it, because it's always in regards to the alternative hypothesis, okay, it would have this tail shaded in. That is P. This is a standardized test statistic. Which is either the Z or the T. Okay. Now the last one is if the alternative hypothesis contains not equal to, what I was doing there, not equal to then the hypothesis test is a two-tailed test. So this one's a little more involved. Each tail has an area that is 1/2 of P, the p-value. Okay, so if the alternative hypothesis is mu is not equal to K, the null hypothesis would have to be that it is equal to K, and then okay, so each of these have an area of 1/2 P because together they make up P. Okay, and then right here is the negative standardized test statistic. And then over here is the positive standardized test statistic. Okay, so those are the different types of hypothesis tests. So now what we're going to do is we're going to go and figure out if we can tell the difference between each of these to see what type of test it is. Now, just to note, the smaller the p-value of the test, the more evidence there is to reject the null hypothesis. Because if the p-value is really, really small, it's basically saying that that's the probability that it will be to happen. So if it's only like 2% that it'll happen, that's very unusual. So, so there's even more reason to believe that you could reject the null hypothesis. So for example number 3, for each claim, state the null hypothesis and alternative hypothesis. We're just going to do it in symbols. Okay. And then determine whether the hypothesis test is a left-tailed test, right-tailed test, or two-tailed test. Sketch a normal sampling distribution and shade the area for the p-value. So a school publicizes that the proportion of students who are involved in at least one extracurricular activity is 61%. So it's a proportion So it's P and it's equal to 61% or 0.61. Okay, so we already kind of went through these. That would be a null hypothesis because it has an equal to. So the alternative hypothesis would have a not equal to. The null is the claim. Now, even though this was the null hypothesis was the claim, we always go with the alternative hypothesis when we're graphing it. Okay, so if it's not equal to, that means there are two tails. Oops, get that guy. Okay, this guy is half of the p-value, which is the probability, or the area. Okay, it's not the proportion. Okay, that doesn't mean that. Okay, it's half of the p-value. I'll even put value here just because I don't want it to get confused with the proportion. Okay, so let's see here. So yeah, this is how we decide that it's two-tailed. Because it's not equal to. Okay, let's go to the next one. And again, we've already done these, so these should look familiar. So a car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, so this is the mean. So mu, and it's less than 15 minutes. Okay, so like that. Now this is strict inequality. So that goes with the alternative hypothesis. And that's the claim. And then the null hypothesis is greater than or equal to 15 minutes because it's the opposite of it. Okay, now we're always talking about the alternative, even if it's not the claim, in order to determine whether it's left-tailed, right-tailed, or two-tailed. Now, since it's saying less than, that would be left-tailed. Okay, so you're going to have some standardized test statistic. Here's the area. And that is going to be the p-value. Okay, cool. Last one. A company advertises that the mean life of its furnaces is more than 18 years. So that's a mean. So, mu, and it's more than 18 years. So if it's just greater than, that's the alternative hypothesis. And then the null hypothesis is the opposite of greater than, so it's less than or equal to. Okay, so now it's always the alternative hypothesis. Take that. If it's more than, then it's right-tailed. So I'm going to have some value here. It's going above. Okay, and right there is the p-value. Okay, so I'm gradually like adding more steps on to set you guys up in order to do the hypothesis testing. So the decision rule based on the p-value. Now, to use a p-value to make a decision in a hypothesis test, compare the p-value with alpha, which is your level of significance. So the two things that you have to make note of here is that if the p-value is less than or equal to alpha, then you are going to reject the null hypothesis, which makes sense, right? Because that would mean it's unusual if it's smaller than it. But then if p is greater than alpha, then fail to reject. The null hypothesis. Okay, failing to reject the null hypothesis does not mean that you have accepted the null hypothesis as true. It simply means that there is not enough evidence to reject the null hypothesis. So I really like this chart. And I'm going to use different colors to show like where these are coming from. So I'm going to start with the decision. So if your decision is to reject the null hypothesis, okay, we have to write quite a bit for these, especially in the decision making. So if you reject the null hypothesis, if that's your final decision, and your original claim was the null hypothesis, well, whether your original claim is the null hypothesis or not, you're always going to start off with there is enough evidence. So there is enough evidence. Okay, we start off our final interpretation with there is enough evidence because we rejected the null hypothesis as our final decision. So now if you fail to reject the null hypothesis, that one is starting off your interpretation with there is not enough evidence. There is not enough evidence. Okay, so the colors are where we get that saying from. So now I'm going to do this in green. Okay. I'll do it in green pen, but I just highlighted it in green. So if the claim, no matter what the decision was, if the claim was the null hypothesis, then you would end it with to reject the claim. To reject the claim. Okay, so that's where the ending comes from. So no matter what the beginning is, if the claim is the null hypothesis, then you end it with to reject the claim, to reject the claim. Now, if the claim was the alternative hypothesis, then the ending there would be to support the claim. Okay. So that would be the ending if the initial claim was the alternative hypothesis. Okay, so let's try to put this into practice. So for example, number 4, you perform a hypothesis test for each claim. How should you interpret your decision if you reject the null hypothesis, if you fail to reject the null hypothesis? So, I'm actually going to type here just because my wrist is kind of hurting a little bit. So if the null hypothesis was your claim, and it says the school publicizes that the proportion of its students who are involved is in at least one extracurricular activity, is 61%, then you could have two options for, I don't want this. Let me see here. So let's say you reject the null hypothesis. And I don't know how to do this. So that would just be the H sub 0. So basically you're rejecting the claim. So if you are rejecting the null hypothesis, I start off with there is enough evidence. Now, the claim was the null hypothesis, so I say there is enough evidence to reject the claim that the proportion of students who are involved in at least one extracurricular activity is 61%. Okay, so that is if I rejected the null hypothesis. Okay, if that was my final decision. Now, if I failed to reject the null hypothesis, let's say that was my final decision, then failed to reject, I'm going to start off with there is not enough evidence to, now, since the initial claim was the null hypothesis, then I'm saying there is not enough evidence to reject the claim that the proportion of students who are involved in at least one extracurricular activity is 61%. Okay, and those would be, so these, I'm going to underline those so that you can really see them. Okay, so if either of those were the final decision, then that would be the outcome from it. Okay, so now let's go down to here. So now let's say that the initial claim is, and I'm just gonna do this here. Let's say the initial claim was the alternative hypothesis. So if my decision was I'm going to reject the null hypothesis, then I am going, and my initial claim was the alternative hypothesis. So if I'm rejecting the null hypothesis, I'm going to start with there is enough evidence. And then since the initial claim was the alternative, I end it in this column. So to support the claim. To support the claim that the mean time for an oil change is less than 15 minutes. Okay. Nice. Now, let's say I failed to reject the null hypothesis. If that's my final decision, then I'm going to start off with there is not enough evidence to, since my claim is the alternative, I'm going to say to support the claim that the mean time for an oil change is less than 15 minutes. Cool. So that's how you can use that chart in order to interpret your final decision. So now I typed out the steps for you guys. There is something that we do have to write in, so just be patient as I go through this. So what you're going to do for the steps for hypothesis testing. So always start by identifying the null and the alternative hypothesis. Write down your level of significance. Determine the standardized sampling distribution and sketch its graph. So that's like the Z or the T. Calculate the test statistic and its corresponding standardized test statistic, Z or T. Add it to your sketch. Okay, find the p-value. And then you're going to use the decision rule. So the decision rule is this. Is the p-value less than or equal to alpha? So is it less than or equal to alpha? If it is, then you reject the null hypothesis. If it's not, then you fail to reject the null hypothesis. Okay, and that's your decision rule. Then finally, you're going to write a statement to interpret the decision in the context of the original claim. So, a medical research team is investigating the benefits of a new surgical treatment. One of the claims is that the mean recovery time for patients after the new treatment is less than 96 hours. Okay, so if you want to support the claim, okay, then that means that the claim should be the alternative hypothesis. Okay, so I would write it as supporting the claim. Then let's see what we have here. Mean is less than 96 hours. Okay, so it's mean. So it's dealing with mu, and this is less than 96 hours. Okay, and that's going to be all our alternative. 96 hours, not 9H. 96 hours. That's the claim. Now the null would be that mu is greater than or equal to 96 hours. Okay, so then, and then our final decision should be, if you want to support the claim, should be that we reject the null hypothesis. Okay. Now it says, how would you write the null and alternative hypotheses when you are on an opposing team and want to reject the claim? So if you wanted to reject the claim, okay, that would mean that now the null hypothesis is going to say that it's less than or equal to 96 hours. And that would end up having to be your claim. So the opposite of that is that it's greater than 96 hours. Okay. So, and then your final decision should be to reject the null hypothesis. Okay, because you're going to end up rejecting that claim. Okay, so any questions, feel free to drop me a message or come to a Zoom or whatever. I'm more than happy to answer it. Okay, otherwise, I hope you guys have a great day. I'll talk to you soon. Bye.